All right, we give thanks to God for this day, and we give thanks for everything that we are privileged to participate in and to have. We call for His grace to be sufficient to us and guide us through this class. This is our praise in Jesus' name. Amen. All right, so we are going to look into experimental design. Yes, I know things like this are very tedious. The statistics, pure statistics through and through. So we need to go through this for us to really understand data science. Yes, we might do Python, we might do all this stuff, but if we do not know how and when and why we should apply all those things, we'll always run into problems to be meaningless. It's like somebody going to the football field and start kicking a ball around and dribbling everybody. You can be a very good player, but the goal of the football is to score. I hope you get it, me. So 11 players goes into the pitch and one person decides to dribble, dribble around the pitch. It doesn't make any sense. It was during, is it 98? When, is it that the coach or a player of one country, Sweden, was asked what it would feel like playing Nigeria? And the man made a statement that playing Nigeria might likely be tough. But what is the use of playing a country who dribbles you but would not score? Because Sweden would definitely take their chances and score. By then, Nigeria had players like Jojo Okocha, who were very good, Kanu Nwankwo and the rest of them. But the man was like, Nigeria can have the possession, that they are not after the possession, that they are actually after the victory. So understanding Python, understanding all the codes, understanding all those stuff will make no sense if we do not know how and when and why we should apply them. So we now come to experimental design. Every scientist should be able to conduct an experiment. So let's look at what experimental design is about. Okay, I asked this question, what is experimental design? If one was to ask, if one was to ask, do you think that owning a car means that one is wealthy? What will likely be your response? Experimental design is concerned about how a fact can represent a population efficiently. Results of an experiment should be such that a typical member of the population is guaranteed to possess at least a quality, attribute, observation identified in the result. Therefore, experimental design is the organization, conduct, interpretation, and presentation of facts for a population. The population is where a generalized question can be targeted upon. So we can target Akwa Ibom State to answer the above question, and we may get a slightly different result if we were to ask same or similar question in Abia State. the response variable. Now we want to discuss things that we actually get while experimenting. When we want to experiment, there's what we call response variable. In mathematics, it's often represented by the letter Y. The response variable Y is also known as the outcome or the dependent variable. If all wealthy people own cars, as we ask the question, does owning a car means that one is wealthy? So if all wealthy people own cars, does it mean that everyone who owns a car is wealthy? This question is derived from the question that we wanted to conduct an experiment on. It was because of that question that every wealthy people, if every wealthy people own cars, so do you think that when somebody owns a car, the person is wealthy? So what would your response be? So now, to answer that question, other questions might pop up. If all wealthy people own cars, does it mean that everyone who owns a car is wealthy? You might also ask other questions from it, but let's take this other point. If you take a sample of wealthy and not wealthy, say 10 people each from a population, say a church, let of those who are able to give above 200 naira, this is 200 naira, or sorry, 2,000 naira every Sunday, be called wealthy. And those giving less be called non-wealthy. We can also group by say 0 to 2,000 naira, 2,000 naira to 5,000 naira, 5,000 naira and above. Let's say 0 to 2,000 naira are the lower income people, 2,000 naira to 5,000 naira. You have something to say?
Yes, please, can you change to presentation mode?
Presentation mode. Okay, you mean the
Slide.
slide. All right. I've even forgotten. Where am I going to click? So where am I clicking?
Yeah, you can use F5.
F5, okay.
Type F5. Okay. Yes. Or slideshow, then you see.
All right, are we good?
Yes, sir. Thank you, sir.
All right. Okay, supposing in a church, we want to split into groups. Let's say 0 to 2,000 naira. Those who are giving every Sunday, they are the average people. Those who give 2,000 naira to 5,000 naira, let's say the middle income earners, and those who give 5,000 naira above are the wealthy people. We can decide to split it that way, just to answer that question that we posed the other time. Now, number of cars is the outcome of the social classes, wealthy and non-wealthy. Therefore, number of cars is dependent on number of wealthy or non-wealthy in the population. So therefore, what we are trying to say is this: the response variable is what we want to ask the question on. So now we are looking at number of cars to decide whether people are wealthy or not wealthy. So this number of cars now becomes our Y, which is the response variable. Now we also have in experimental design, we also have the explanatory variable. The variable independent of whatever you asking of, you are asking of, sorry, but required to obtain useful responses is called the explanatory independent or predictor variable. You can give them any of the names. So it is a variable X. A car owner may be poor and is given less than 1,000 naira every Sunday, given whatever economic challenges not in the scope of the research. Remember, this poor I'm putting here is just an assumption because the person owns a car. So what defines a person to be poor here is because he's given less than 1,000 naira. Remember, we want to solve that problem. So we are the ones to decide how we want to group the people. So by grouping, this person happens to fall under people that are giving less than 1,000 naira every Sunday. So because of that, we call the person poor, but the person owns a car. I hope you understand.
Yes, very well.
Okay. Given whatever economic challenges not in the scope of the research. A student who is on adequate scholarship and not a car owner may be giving 10,000 naira every Sunday to the church. So all these people fall under the explanatory variable X. They are independent of each other. They don't know what you people are trying to do. They are minding their business, doing the things they are supposed to do. But you are the one trying to solve a problem. Because of that, you are dragging them into the experiment. So that is why they are called independent variable. They did not call you, come and test us if we are rich or we are poor. Understand? They are minding their business.
Okay.
But because of the argument that everybody that owns a car is wealthy, you now decide to drag them into the experiment. The idea is that they are independent of, not related with each other, but are here observed to answer the question that number of cars determines wealth or wealth status, as the case may be. Now, factor. We are going to see all these things in that text. I just summarize these things in this presentation. We will really use that text that I shared to do lots and lots of explanation on this. But let's just look at this. A factor is a collection of treatments or subjective conditions that are related but of different degrees. So if we are to factor the wealthy and non-wealthy, we may say, okay, this one is 18 years old, this one is 40 years old, this one is 60 years old. Those are factors that determines their age. Those are factors, sorry, those are subjective conditions within the factor called age. So we might treat them according to their age. So Education is a factor. Occupation is a factor because somebody who is working in the government house or somebody who is working in mobile may likely not earn the same as somebody who is working in the local government. So occupation is a factor. Health is a factor. If the person is sick, you cannot classify that person as wealthy. Even though the question, given the question that we posed, that car owners are wealthy, the person may own a car, but the person is not healthy, and the person cannot afford certain basic things. So the person owning the car does not necessarily mean the person is wealthy. It's a factor. Occupation is a factor. Education is a factor. Age is a factor. So the idea of factor in experimental design is that there are certain times that we need to treat subject certain treatments. So we need to look at factors. If we have it by age, we might split people into age. If we add them by education, we split them by their educational qualification, occupation, and the rest. So we might treat them differently. So there are subjective conditions related, but of different degrees. So somebody that is under 18 may not necessarily own a car because it should not own a car at that age. And somebody who is from age of 80 upward may likely not drive a car. So somebody of a certain education may likely not be able to understand how to use a car and the rest of the thing. So in the age factor, it may be illegal for a wealthy, non-wealthy to drive a car at certain age groups. Factor analysis leads to analysis of variation. So whenever we talk about factor, we come up with comparison tests like t-test, ANOVA, and the rest. So somebody, like what I saw in one of the texts I was reading, two conditions. One person was, let's say a group of people, 30 people were working in a particular place. So they took them to a similar place, but in a tougher condition. So they were assessed on their performance. So each person had two different averages of performances by number of days. So by that, they needed to do a t-test to see if this condition really, to what degree did it affect the previous condition. So within a factor, we test degree of variation. So under the age, we might test degree of variation between somebody that is 18 and somebody that is 50. Under occupation, we might test the degree of variation between somebody who's working in such a place, let's say mobile, and somebody who's working in the local government. Under education, we might test the variation between somebody who has a BSc and somebody who has a primary six. Is a primary six person likely to own a car, or is a degree person likely to own a car? So we may also test variation between health. So in order to test variation, we have the t-test. Some factors are treatable. There are factors that are actually treatable. If somebody is underemployed in occupation, the person can be treated, updated to become more employed. So somebody is sick, it can be treated to become healthy. Like, why do I say factors are treatable? If you want to test certain things and you want everybody to be on the same level, you have to upgrade other people and place them at that level. A typical example, it might not happen with human beings, but it happens in material things. If you want to test the weather condition, you must start at a particular level. You cannot test weather when there are still different weather conditions in different places. If you want to test rainfall, you test it as rain is falling. Understand? So if you want to check the amount of rainfall, you will not say, oh, rain is falling in Uyo, rain is not falling in Calabar. Okay, let me go and test rainfall in Calabar when rain is not falling. You have to wait. The test has to wait until rain falls so that you can check the volume of the rainfall. So some factors are treatable. You have to wait, or either you treat it or you wait until it attains certain level that you can actually include it in the experiment. The church may organize programs to address the education of its members, health situation. Those are treatable factors. We all know that there are certain kind of research that are for people who are 50 years. So you have to now wait for members to be up to 50 years before they join such research. So that is just it. So in every experiment, you must have your target population. And where some population cannot meet the requirements for you to have the number of people that you need for that experiment, you can treat others and upgrade them until they meet that. Either you treat by time, you wait for them to attain, or you treat in terms of animals. You see some animals given, in terms of plants given fertilizer and the rest so that they can grow. Some factors are treatable, but you cannot treat age. You have to wait until somebody gets to that, gets old to that age. Some factors cannot be treatable. You can change somebody's occupation, but there are some things you cannot change. There are other terminologies like nuisance variable, systematic barriers, experimental units. These ones are easy to understand, but I want to explain experimental units and measurement units. Nuisance variables are variables that influence the response variable but are not of interest. They are not of interest because you did not include them in your scope. Example, if you want to check level of absenteeism and lateness, you may not go and say, oh, rain fell at Uyo and did not fall at Ikorekpene. No, your experiment is strictly on how people are able to come to work early or absent from work. So you may not be thinking, oh, this person had a minor accident somewhere. Oh, there was rain falling somewhere. Or this person, his road is not tarred. So because of that, there is flood. He cannot drive out. Those things are not your concern. They are not part of your scope. So they are called nuisance variables. So as much as possible, you assume all things being equal and let them go. So like this age, I talked about age. Sometimes you might ignore somebody's age. So that's it. Then we have systematic bias. Systematic bias is a result of us ignoring those things I just mentioned. For example, somebody might have a genuine reason for staying back from work, but because our experiment did not ask, why did this person stay back from work? Because of that, it resulted in systematic bias. So we are now biased. So it becomes a confounding variable. So that is why most times, whenever you are doing an experiment, you make it as random as possible, such that if there is the systematic bias can be very low, such that you don't pick only people that have that same problem. That's what I mean, random. You don't pick only those who live in that area that will always have challenges, so that you will not have problem in that experiment. You can pick across different locations and see if they are committed to work. Understand? So by that, the other people doing well might augment this other person that could not do well because of his challenges. So that is how to solve systematic bias. Experimental units. Yes, experimental units is like you want to, I talked about people owning cars being wealthy. I've also mentioned about people coming to work, attitude to work, either coming early or staying away from work. The idea of experimental units is that supposing I want to see if my church members, because they own cars, they are wealthy, I might split by age, I might split by education. Understand? I might just group, not necessarily by age or education. I might just throw it random. Okay. I now draw let's say I draw a line, like three different lines. I say 5 people stand here, 5 people stand here, 5 people stand here. All people that own cars, all of them, they stood there. Each of them, each of the group of people are called experimental units. I might pick like two out of those five. So each of them, or each of the five are called experimental units because I splitted them into 5 groups. Now, measurement units. Measurement units might be this, let me not say might be. Measurement units are the people that I'm actually experimenting on. So after lining, let's say a group of five, up to 3 or 4 groups, I now say one male, one female come out from each group and make them 2. By bringing those two people out, I want to see if they own cars, or because they own cars, I want to see how much are they giving to the church. And out of the 2 people, whatever they give determines how I place them, whether they are wealthy or they are not wealthy. Those two people coming out of each group are called measurement units. Why do we have experimental units and then we have measurement units? The reason is that for us to avoid bias, I talked about systemic bias. For us to have bias, we have to group the population into units. And from that population that we group, we take experimental units out of them. From these experimental units, we take out of them. We cannot examine all of them. We have to pick them by random. By picking them, each of the ones we are able to pick, because we cannot measure everybody, are called the measurement units. Yes, you might say, why don't we just attend to the 15 people? That is 555 people, because they are small population. Yes, we can do that if it is a population that is small. Assuming it's a population as large as the entire city of Uyo, we want to see if the people living in Uyo who own cars are actually wealthy. You cannot do it because the people are much. So first of all, you can decide to group them by either their location, where they are living. Are they living in shelter Africa? Are they living in so place? By grouping them, they are called experimental units. Then you now sample. Let's say you want to sample 30, 30, 30, 30 from each of the groupings. Each of the 30 you have sampled out are called experimental units, because they are the ones actually representing each of their units. Like in politics, we have polling units. So they are the ones telling you, this my unit is either doing well or not doing well. So that is why they are called measurement units. Now, a plot assigned to receive a particular variety, a subject, in terms of a plant. If you go into a farmland and you want to do an experiment, you cannot experiment all the plants in that farm, on that farmland. There might be up to 10,000 plants. So what you do is to split the plant. You might use a ruler, divide the plant into 10, the farm into 10. After dividing the farm into 10, you can sample 10 crops on each plot. Each of the 10 are called measurement units. Then the division into 10 is called experimental unit. I hope we understand them.
Yes, sir. Yes, sir.
Now,
Yes, please.
another thing I want us to get when we are talking about experimental design is this: experimental error. Variation among experimental units are very genuine. Understand? It might not be the cause of it. They might not be the cause of it. It might be some factor unpredictable, some factors nobody knows, some factors that have been there, some factors that you cannot even correct. Like I talked about somebody coming late to work. It might be, it may have been, because of that experiment, as in showed that the people failed. But in actual sense, the person given a better condition may have succeeded. So variation among experimental units that have received the same experimental condition, the standard against which differences between experiments are to be judged. Treatment differences must be large relative to variability. So when you observe that there's a possibility that a member of the experiment or a member of the data might actually fail an experiment, what you now do is to increase the number, but do it randomly. change that particular location. Try as much as get as much data as you can. By that, you'll be able to reduce the experimental error. By that, some other person who may have the same attribute as the other person who is failing because of the situation the person is, but is in a better situation than the other person, might augment this other person. So in terms of plants, a plant standing in a place that there's more nutrients, understand, in that particular point, might augment this other plant standing next to him, but nutrients is not very much in that point. So it will augment. So you take the average of the two of them. So that is experimental error. If two varieties have mean yields that differ by the unit, no way to judge how large D, that is the sorry, how to call it, the difference, there's how they call it, yeah, displacement is, unless we can estimate the experimental error. So you have to check the difference between this one standing close to this other one and check how they vary. So you know if the variation is large, you have to increase the number in your data, bring in more for experiments. But if the variation is small, you know that your experiment is doing well. So we now, because of that, in all these errors and the rest, we now employ what we call randomization. So that is for the explanation on experimental design. We will go into the text proper from tomorrow. So we will try as much as possible to look at the different kinds of experiments. There are other terminologies, there are things we need to understand. We'll go through in the text that I shared with us. So experimental design is a very nice course. Understanding it is going to really help us in furthering our studies in data science. Thank you very much for your attention. Please, do we have questions?
Yes, sir.
Okay, please go ahead.
On randomization.
Randomization. Okay, you want me to explain?
Yes.
Okay. It was intended. I want to avoid randomization until we get to the text proper. But let me give us an idea of randomization. A lot of people think that randomization is actually what we call a kind of haphazard, okay, let me just close my eyes and pick something. That is not randomization. Have you ever seen a drunk walking? Have you noticed how a drunk walks?
Yes.
Okay.
It's
But
staggered.
if the drunk actually knows where he's living, you know he's going to reach his house.
Yes.
But how does he walk? He walks as if he's going to fall. the idea of randomization is that ability to take into account everything that is going to stop you from getting to your destination. But you are able to get those data, take those data, get those data, instead of having a straight point data. If I want to know, I hope my network is not having issues. All right. If I want to get data, like I talked about, getting data of people who drive cars to know if they are wealthy.
Okay.
Let's look at the question now. If one was to ask, do you think that owning a car means that one is wealthy? Now I want to obtain the data. This is how randomization works. I might say, I go into the church. Nobody knows my intention. I just get up. I say, if you have a car, come out and pick this. Let's say I had folded sheet of paper and wrote there 1, 2, 3, 4, 5. Come and put any of this paper wherever, whatever number you have, stand there. I hope you understand me to that point. Have you gotten me to that point?
Yes, please.
Okay. So out of the people that own car, I had folded only 30 papers. But people don't know that I folded only 30 papers. So people just got up, started picking. Whatever you pick, you stand there. If you pick 1, you stand at 1. If you pick 2, you stand at 2. If you pick 3, you stand at 3. If you pick 4, you stand at 4. If you pick 5, you stand at 5. Now, I am able to get six people per line. Then the paper is finished. Others will be coming out. I say, the papers are finished too. I say, don't worry now. You people did not come out early. Now, that is randomization. I am able to get people who own cars and be able to give them where I want to assign them as experimental units. Understand? Without them knowing, I think there is no manipulation. I have designed the experiment, but I have made it random, such that if we are going to get to our destination without tailoring the experiment in terms of by saying, okay, I know you have a car, get off, stand here. I did not pick people. They pick themselves, but they are fitting it according to the experiment. It might be that the people that are picking this don't have the kind of car I am looking for. It might be people who drive anyhow car. It might be people who drive big cars. So that is not the idea. So now, I now said, out of the 5 people of each of the group, I need to know who are wealthy in each of the group. I now say, five of you, all of you, you are going to do something for me. Drop your offering. Now, in my experiment, everybody that gives above 2,000 naira is wealthy. Everybody that gives less than 2,000 naira is not wealthy. But they don't know. They just came out. Somebody might decide this man too like money and gives 100 naira. He does not know that I'm doing an experiment. But the other person might say, senior, I get cow. I don't need for my hand. Give 5,000 naira. That is how randomization works. Then from there, I can now say this group A, group one person is wealthy. Group two, nobody is wealthy. Group three people are wealthy. Group four, like that. By that, I now take the averages of the wealthy people in that church. I now use it as a fact, a representation of my church. Because that person that did not give will not likely give somewhere else, given the same condition I have in my church. Are you getting what I'm saying? All conditions being equal, he may likely not give, even if it's in another place. But supposing the conditions change, he might give. But that is how I want to design the experiment. So the idea is you have to design your experiment and take into account randomization, such that the experiments, the data you are using for is not tweaked just because of that experiment. The data is gotten randomly. I hope you understand.
Yes, very well. That's your
It is not an hazard picking. It is a design, but it has to be such that the data volunteers itself and you get what you want. You can use a dice. Say, okay, if you pick 2 or if you pick 5, stand here. If you pick less than 5, go and sit down. It can be cards, but some cards are biased. That is why some people avoid using cards. It can be computer-aided number. You can say, oh, it can also be on the decision of the members. You can say, every member that came to church from 9 o'clock to 9:15, those are the people you are interested in. Everybody that came from 9:15 down are late. I don't want those people in my experiment. It is random. You did not tell them, but you just want to experiment on those people. So that is how to randomize an experiment. I hope you understand. You can apply the same thing in plants. You don't have to say, oh, I want to experiment that particular plant. No. You need to say, okay, which plant should I pick? You throw a dice or you do a random computer number out of this list and it gives you a number and you go to that point and pick, okay, next random number, and it gives you another one. If it repeats that same point, you skip that one and do another one. Go to the next random number. So that's just it. You randomize it such that you don't concentrate on a particular data point. If you concentrate on a particular data point, you have bias. So that is it. Any other question?
I'm fine. I'm fine.
Fine. Any other question? Are we good?
No question from here.
All right. Yes, you are going to say the closing prayers. Since you said no question, you are the one that have not said anything. All right. Please indicate in the group so that I can send you your data. Just drop your number. I can send your data. Thank you very much. Please say the closing prayers. Oluwaseun.
Okay, Father, in the name of Jesus, thank you for the privilege to learn again. Thank you for the wisdom that you have bestowed on our lecturers. Thank you for your love that surpasses human understanding. Daddy, as we are going to sleep tonight, we pray that you give us retentive memory in the name of Jesus. And tomorrow, grant us the grace to be able to gather again. Make us to be useful. Whatever we are learning, make it to be useful for us and make us fulfill purpose. In Jesus' mighty name we have prayed.
Amen. Thank you, everyone. Good night. See ya.
Good night. Thank you.